Hi, everyone. For those who already joined, we'll be going live with the session in about 1 to 2 minutes. So we'll just give it a few more minutes and then we'll start. Cool. I think it's time to get started. Thank you so much for joining this webinar. This is actually the first time that we do a webinar like this, which is a webinar focused on the development side of Unity Playworks, formerly known as Luna. So just so you know, we call it Unity Playworks now. It used to be called Luna back in the day. So we might have some overlap in people saying Luna or Unity Playworks. It's the same thing. I'll start with a short introduction of myself. So I'm Robin. I lead the business side of Unity Playworks, which means that I take care of the platform side, of the business side, of the contract sides, all of that. So I don't know too much about the technical part myself. Luckily, we have Shahar here. Besides me, there is also a engineering team and a support team. So for technical support, and the engineering team is the product team. So that all makes up Unity Playworks. And today we have Shahar. He will be presenting. He is part of the Playable production team, and he has produced playables for all major studios. And he has been doing that for a few years now. And so he has been working with Playworks for a long time now, and he has built playables across different genres. So he has a lot of experience. So Shahar is really an expert on how to build playables using Playworks, and he's here to present about that today and do a live demo as well. We received many questions of you, and although some of the questions were more related to product features or product requests, that's not the goal here today, right? There's no product or engineering team here today to talk about the roadmap or what's coming, or to say like, hey, this is a feature that we will add. So this is really Shahar showing what the product is, how he uses it in his day-to-day. So he will speak about the capabilities of the tool, but also about the limitations of the tool, and then how he handles those. So again, there's been many questions, again, like product feedback questions. All of those feedback or questions have been heard and will also go to the engineering team. And then there's also some more developer-specific questions that Shahar will answer today. And again, this is the first time we do this setup, so feel free to share any feedback after. And we'd also would love to hear from you if there's anything in the future that you'd like to see. So without further ado, Shahar, I'll give the floor to you.
Hey everyone. So let me properly introduce myself. My name is Shahar Butz, and I've been a Unity developer for 7 years now, and 5 years out of those were purely on playables through Playworks. I've made playables for tens of different titles: Angry Birds, Marvel Snap, Brawl Stars, Monopoly Go, Royal Match, Subway Surfers, tens of different others. And because of that, I developed a myriad of different mechanics in the environment of Playworks. Casual games, puzzle games, action games, customization, and such. That's where the experience that I'm about to share with you basically came from, because naturally, when I worked on different mechanics and types of games, I encountered specific Playworks issues for those mechanics. And like Robin said, just as a small disclaimer again, if this wasn't clear, while I am and have been an in-house playable developer for Playworks and Unity, I'm not a developer of the actual plugin. I did not make the plugin or actively develop it. Any frustrations that you have with the plugins are ones that I experienced myself, and we are going to talk about some of them. Now, my aim here today is to try and help you minimize issues and frustrations when you try to develop a playable using the plugin. And before I get into anything truly technical, I will first and foremost tell you about the mindset that I work with. So the Playworks mindset, every game is a unique project. It makes it pretty much impossible to predict in advance what kind of technical hurdles you might run into, what sort of issues will pop up. So rather than just react to bugs as they come, a bug pops up and you solve it, we want a more proactive strategy, avoiding issues in advance. And the way we do that, the way we can avoid all the common pitfalls before they even happen and drastically reduce debug time, is by following a few simple principles. So before I even open my project, these are a few things I take into mind. So the first one might be the most obvious one. You probably heard of keep it simple, stupid, or just keep it simple. In my opinion, the ideal way to start a Playworks project is to start from a dedicated, empty project, rather than from a finished project or a template or the main branch of your game if you work in a studio. Maybe you're a publisher and you have the full project from your client and you're making a playable for them. It's very tempting to use a finished project and resigning to the fact that the majority of the work will be around solving issues as they come up or graphical issues as they come up. But most of the time, you'll easily find yourself encountering so many issues that you would have wished you had just started from scratch. An outlier to this, I would say, is if you already created an isolated project only for playables, not a separate branch on GitHub or any source control, but rather, yes, we are recording this, so you will be able to see the slides and see all the content. So you don't want to start from scratch. You don't want to start from another branch where you have your entire project sitting and only a separate scene. You want a complete project only dedicated to your playable. And ideally, when you do that, when you have that isolated project, you also want to develop the pure game mechanics first and not focus on any graphics at first. Graphical issues are their own separate subject, and you can just avoid them if you work in this method, just pure game mechanics first. A small anecdote on this: if you have to start on a finished project, or if you think you know better for one reason or another, I still implore you to make an isolated version of that project, export that isolated version onto a new project that only has the bare necessities, only the actual scripts that you need, the graphical files that you need, because the way Playworks works is that it goes through every single shader, every single script, every single file in your project, and it tries to process that in some way and to see if you use that or not. And if Playworks encounters a file it doesn't like, I'll explain more what that means later on, you might get black screens, infinite loading screens, a broken mechanic, and worst of all, you won't have an error that actually has a stack trace that leads anywhere. You'll just get an error and wonder why nothing is working. But hopefully you'll never reach this point by sticking to these principles, and I will talk later on what to do if you have unfortunately reached that point. The second and last principle, I cannot emphasize this enough: build often. You have your isolated project, you are working mechanic by mechanic, you want to build after each time you finish making a mechanic. You'd be surprised at what might cause issues in your project, what might be unsupported or create a bug or a weird edge case quirk. The simplest stuff that you think might be very bare bones, but in hindsight, it's clear why the engine has trouble with them. Basically, the worst thing that you can do is only try building when you're finished with the entire playable. I see people do this all the time, especially when they start out. They first finish the entire playable, then they start building to Playworks, and they encounter tens of issues. They find out that one of their systems is entirely unsupported and they have to refactor that. You could save yourself days or even just hours at the best case by just doing these 1 to 2 minute builds and quickly testing your mechanic. Each time you also connect it to another new mechanic, you want to test the connections, stuff like that. I cannot say this enough. Build each time you finish something. Work in milestones, basically. Now that we've finished this theoretical part, let's get into the actual engine. I'm going to talk about the features and best practices as you work in Playworks. Now, because these are stuff that you need to do in every single project that you work on, regardless of mechanic, regardless of genre, some of you are already familiar or maybe even really familiar with some of these. But I'm going to still go through each of them because they're very important. The first one that I would guess most of you are familiar with, if not all of you, is configuring game variables with Luna Playground fields. Well, now we should probably call them Playworks Playground fields. I still thought I'd quickly mention them and show you the full extent of what you can do with them if you only use them in their basic versions. So the very first one is the Luna Playground field. This one can just be used to configure simple game variables. This way, you or your game designer or anyone on your team or your client, they can create different variations of your playable, which is extremely important. Obviously, we want to A/B test many different versions of our playable and see what users best react to. And by simple values and variables, I obviously mean stuff like speed, health, gravity, maybe more complex stuff like what level we start the playable on. Then we have the less used sort of field, the playground asset field, which is brilliant. I love it. It lets us upload specific types of files onto our playground once the project is done, like images, sounds, videos, fonts. And this one is terrific for making reskins. Let's say you finished your playable months ago and it's Christmas now. The playable is doing great, but you want to create a Christmas variation to increase interaction. So we have our original Angry Birds playable over here. And I just put every single asset over here in as a Luna Playground asset field. And a designer from my team can go in later and replace each and every one of these assets very easily. And the gameplay is entirely the same. And this way I can create Halloween season variations, Christmas, or maybe I want to update all the assets if the game went through a graphical rehaul. Maybe we just want to test different levels as we launch the playable. This is great for it. It also helps us save on room because we obviously can't upload 3 different themes with 3 different types of graphics onto the same HTML. That would weigh a lot. And finally, the less common use for playground fields is to create level editors. And instead of describing this, let me actually show you something that I made way back when. This first one was for a match-3 game called Small Town Murders for Rovio. We start on this simple configuration that is cross-like, basically. And I wanted to give the client an option to make whatever level they can dream of. I didn't want to limit the amount of columns and rows or power-ups or anything of the sort. And the way I did this was using asset fields. Basically, let me show you what sort of asset I would upload in order to make it into a level editor. Each one of the colors in this pixel chart corresponds to a piece in the game. I just told the code to go over the texture and filter out the colors and see which one needs to go in each row according to pixel placement. These are the pieces that are coming next. And now, all I have to do is just browse onto my files. I can just drop an entirely new different level here and drop the pieces that are going to come next. And bam, just like that, with minimal work, any game designer, anyone from my team, any client can just design their own level here. Extremely useful. It minimizes the amount of time your team has to go back and communicate with you. If you're independent, it heightens the value of your product, obviously, because this is way more dynamic. They don't need you for every single small change. I even made it so they can decide which piece gets matched to which direction automatically if the user doesn't interact after a few seconds. And if you want to do a more robust level editor, that's also an option you have. What if we wanted to do something that's not plausible with just fields? In this case, we can work a bit harder and create our own external editor. This one I just hosted as a test in HIO. This one is for this template Playable, which basically runs on video files. My team uploads video files and they can create a branching choices experience. So actually each one of these buttons leads to an entirely different video in a branching tree. And some of these lead to a failure and an end card. And it does all of this based on this JSON output. And if I throw this into my external tool and load it, you can see that you can actually manage the tree over here. You can drag new scenarios in. You can decide on all sorts of video settings in the different menus. And you can create endless loops. You can do basically whatever you want. And the developer, me, doesn't have to touch this ever again until he gets requests for updates, maybe. So really, there's a lot you can do with these simplified fields, way more than you can probably imagine, way more than maybe even I can imagine. But let's move on to our next feature that you should be aware of. This is a pain point for many of you. Many of you are familiar with the shader collection of Playworks. And you are also very familiar with the problem of pink materials, pink shaders that don't get compiled properly after you build. Let me actually show what this window looks like for those of you who never actually dabbled with it and just let it run automatically before I talk about issues and solutions to said issues. Oh, sorry. Here we go. All right, so when we open our plugin and we go to the Runtime Analysis tab and we go to the Shaders tab, the first time we build our playable using build develop and each subsequent time, basically, it goes through our scene, it goes through every shader that we actually use, and it puts it into a nice, neat file here in our root folder, in our assets folder, called SVC Luna. SVC stands for Shader Variation Collection, Variant Collection. And it basically collects only the shaders that we actually need. It does that to greatly minimize the this file size that we use, the amount of time it takes to build develop, and the amount of time it takes for a user to actually load the playable when they come across it on their phones. You can see that this one just has one shader that it got for me and all of the necessary tags. And you can obviously also go through your entire shader list and manually add stuff and specific keywords for those shaders if you need to. Now this, in an ideal scenario, works automatically. But sometimes it fails. It can fail for a large variation of reasons. Unfortunately, maybe you spawn enemies into your scene, so the code doesn't have a reference to the actual shader. Maybe you replace materials as the game runs. And most of you are already familiar with the very first fix. The very first fix is to simply delete your SVC Luna file. This forces a recollection of all the shaders in your project. So if you build something and it's built before and everything was fine, but suddenly it has pink materials, you want to simply delete the files. It will recollect all the shaders again. If that also failed for multiple runs or it fails way too much, you can go in and manually add that specific shader alongside any required variants. And like I said in the principles, keep it simple. You don't want to use complex shader features. You don't want to go too fancy. If you can do something simply or with a simple workaround, please use that. We are still running on WebGL2 here. That means our pragma target can generally not be above 3. If a shader fails each and every time, maybe you use unsupported shader features, maybe your pragma target is too high. In rare cases, maybe you use an unsupported URP version, Universal Render Pipeline. If I hop onto the documentation real quick, You can see that for each Unity version, we have our supported Universal Render Pipeline version. A quick anecdote about Unity 6 in particular, Unity 6 is always going to give you the updated version of Universal Render Pipeline. Usually it's not going to be this version. That means when you open a brand new project, you're already with an unsupported version. Hopefully this will get fixed in the future, but currently we need to work around that. And if you have a shader that never passes, my suggestion is to try and use a simpler version of it. In general, I always try to use the same shader for everything in my project, if possible, unless it's for different effects. Runtime analysis, our next feature, the most important one, in my opinion. If you haven't paid attention so far, please pay attention now. Just like the shader collection, it's meant to reduce our build size. It calls any piece of code that doesn't get actively used in build develop. This means also pieces of code that has to do with the core version of Unity, not just your scripts you wrote. And most of the time when you upload something to Playground and it's broken despite working in a build develop, it's because of runtime analysis. I cannot stress this enough. If you didn't do a build develop and play something after you finish a mechanic, it's not in your game. You didn't play it, it's not in your game. So after I finish each mechanic that I work on, I immediately build and test it in build develop, obviously to see that it's running, but also to make sure that every single piece of code that I need ran at least once in build develop. I also do this before I do the last upload to Playground. And if you find that you have an issue and you suspect that code stripping is the culprit for this, you want to go in and disable code stripping, retest your mechanic, and see if it gets sorted. And that way you can know that it's due to code stripping. I didn't say this, but the way you make sure that it's active, you go to the Runtime Analysis tab. If this is checked on, disable code stripping, you're currently not stripping any code. You should definitely keep this check mark off and do strip the code. Code can go up to even 2 megabytes, 3 megabytes, which is not ideal for our playables that need to be very lightweight. All right. And a small anecdote on this, if you think you just made a very small change in your project and you shouldn't rebuild anything, in one of the last projects I did, I had enemies spawning in a circle. I merely wanted to go into their collider, bounce extents, which is basically just half of the collider, so I can offset them to be just outside the player's screen. I had references to colliders before in my project and parts of colliders, so I thought for sure that it was included in my runtime analysis profile. So I uploaded immediately to Playground after making this change. And apparently it had references to colliders, but not to bounce.extents. I got a null error, and my enemies immediately broke down and stopped moving. So again, after each and every tiny change, you unfortunately have to go back and make sure that it actually runs. All right, these were stuff that you should do in every project. These were common stuff. Maybe some of you were already familiar with all of them. Now I'm going to get into common workarounds for different and specific mechanics. Okay, so first of all, if you use any sort of physics in your project, this is for you. This is about performance with physics and about consistency of physics. I have 3 points here. First of all, what do I do if my project has a large number of rigid bodies that I need to react to my player? Maybe I'm working on Angry Birds or something of the sorts, and I need towers that can collapse. Maybe I'm working on one of those hole games, and I need a large amount of objects to fall into a hole. Obviously, this cannot be very performative in Playworks, having all of these objects constantly active. Also, Playworks only updates the physics once every maybe 6 frames or more, I think, on contrary to Unity. That means that these beautiful piles of objects here cannot even sustain themselves. They would immediately fall apart. What you want to do is use a sleep manager. All of these objects have to be kinematic. Is kinematic will be on in the rigid body. This means the objects are not actually simulated in the physical engine until we unfreeze them. The sleep manager knows when it needs to unfreeze something. In this game, in this whole game, for example, I only made them unfreeze when the player is close enough or when the hole is right below the objects, and I refreeze them if they aren't above the hole for 0.2 seconds or if their velocity dot magnitude is below a certain threshold. This is how I manage them. I got this complaint a lot, and I heard this a lot. This is probably a pain point for many of you. When physics are not consistent between Unity and Playworks. And for games, in this specific playable for Angry Birds, where I needed very specific physics to do this H shape across planets and hit this building, I needed very specific physics. The solution that I ended up working it, and the solution to your problem is usually the easiest one. I simply used Luna Playground fields in order to reach the closest values that I needed in order to simulate whatever is happening in Unity. I know that this can be unfortunate if you work with a lot of values like launch force, gravity of different objects, stuff like that. But this was the best solution that I personally found up until now. Before I did this tweak, my bird would just go outside the screen or just stick to the planet. It could not do this pretty 8-figure. What if I want to do a large explosion of many rigid bodies in my game? What if I make it an ASMR game and I want many objects to fall down? I have another technique for this, but in this specific scenario, I used physics baking. What I did was basically create, or I think there's always also an example of many scripts of this online, honestly, scripts that just bake the position and rotation of all of your objects in an array onto an animation clip. And once it's an animation clip, they don't have to be actually physically simulated whatsoever. And they're 100% consistent across every single device. And when you record an animation like this, obviously, you want to make sure that you don't record too many frames. Otherwise, that animation clip is going to weigh a lot. And that can also be detrimental to your playable. I suggest like 10 to 15. That's usually enough for achieving ASMR or explosion effects. You simply press the record button, press the explosion button, stop recording, and use that. All right, this was about physics. Now grab a quick sip of water. All right. Anyone who uses particle effects, you probably already noticed that particle effects can sometimes be inconsistent between Playworks and Unity. I work with particle effects all the time. I'm a big believer of juice in your games. And what I do to go around that inconsistency is basically use the Luna debugger. And I'm going to demonstrate it real quick if some of you are not actually familiar with it. Here we go. Now, the Luna debugger is simply an extension that you can install to Chrome. You can find it in the documentation. You can find it by simply Googling it and installing it onto your browser. Now, right now, I wouldn't be able to see it, but usually you see it by pressing right-click, inspect, and you go to your tabs and you search for it. Now, the reason it's not appearing right now is that there's a bug in some Unity versions right now, and you have to add /iframe.html. This gives you like the full HTML view of your playable. You inspect again, and this time we have the Luna debugger over here, and just like you can see, it's exactly like the Unity inspector, but remade from the ground up for Playworks. Now, in case you didn't notice, the particle system in Playworks was also obviously, like everything else there, made from the ground up to imitate Unity's particle system. And it does not support certain features, unfortunately. We can also see all of said features over here. We don't support collisions, trails, custom data, sub-emitters. These are all very painful for me. I love particle systems. But what we want to do once we get to this point, we want to go and tweak with the values until we get an effect that looks like our original particle system. So I can change this cone to be a circle if that looks better in my opinion. I can decrease the simulation size the simulation speed. Maybe that looks better in my opinion. Add some gravity. I can do anything really. Change the color. Sometimes in very rare cases, you might have to restart your particle system by quickly disabling and enabling it. And simply remember what changes you made and rewrite those changes in Unity. Or if you want to be very elaborate, create a switcher script that switches values between two different particle systems, depending on whether you're in Unity or over here in your build. Again, these are not perfect solutions. This is precisely why I call them workarounds. This is what I do for each and every one of my projects. Yes, it takes some extra time, but it's worth it. Also, a quick anecdote about the Luna debugger. You can use it for any sort of debugging, obviously, not just this specific function. I use it many times to disable problematic UI objects and try and see exactly who's the culprit, who's blocking one of my buttons, or stuff like that. Okay, now on to the next workaround, lighting. This is probably the biggest pain point for anyone using 3D in our playables. And you might not like very much what I'm going to say, but in each and every one of my projects, I try to always opt for going unlit. I don't use the lighting system at all. This is because I'm trying to maximize on saving performance. I'm trying to make it so each and every device sees the lighting exactly in the same way, the same colors, everything. But what if I want shadows in my playable? Okay, so for character shadows, I just use a blob shadow, which is basically just a small circle at the base, at the bottom of your player's feet. I know some of you really like real-time shadows, but I can promise you for a 20 to 30-second ad, most of the users are simply not going to care. They will care more about content than small points like this on your graphics. But what do I do for actually lighting the models themselves? So obviously you can bake lights in Unity. Some of you are familiar with this, but you cannot bake non-static objects. So the solution I have for this is a specialized script that can, let me minimize that, a specialized script that can bake lighting onto characters. You can do this in Blender too, if you know how to, but I do this in Unity. I used to write these scripts myself, but in the age of AI, any of you, I promise you, can make this script in like 30 minutes tops and your own version of it. This script takes an unlit character with a basic unlit shader that already comes with Unity, and using the multiple directional lights in your scene, and I suggest that you use multiple lights to make sure your object is sufficiently lit on all sides. You can simply bake the lighting data directly onto your character, and you can see that if I rotate it, the shadows stay the same, so you know that it's actually baked. The players are mostly not going to notice if you do this correctly. And just as a quick demonstration, I'll show you how mine works. All I have to do in this workflow, and I can do this for multiple objects at once, obviously, I go to my material, I choose whatever unlit texture I need to have. Let's switch to our scaler here. I opted for light amount. If you want to copy my values, you can go back to the recording and just look at them. The script itself is not how to make. I use another shader that knows how to record the lighting data. And you don't have to write the lighting data directly onto the texture. You can write it onto its own separate texture and use your own complicated shader to combine the two if you prefer it for some reason. And I simply press bake. It asks me where to save it. I'll replace my current one, and bam, it's baked. My character can now even animate and freely move despite being a skin mesh renderer, and the light stays where it should be. So this is how I do everything unlit. So I told you the pros of this. If you absolutely have to use lighting, maybe someone in your team, or maybe you insist on it, the main point I have to tell you, you probably already noticed that sometimes lighting looks different in your scene than it looks in Playworks. You just have to go to build settings. This solves it most of the time. You go to player settings, and you need to look out for color space. Currently, it's linear. We want to have it as gamma, or the opposite option, obviously, if gamma is the one that's giving you issues. This will greatly change how colors look. I could reach a scenario where I'm on the wrong color space and I color pick different objects, and they have like entirely different hues between Unity and Playworks if I don't pay attention to this on lit objects. Okay, so this was about lighting. I did say I would talk about this. Black screens, infinite loading screens, errors that don't have a stack trace that actually leads anywhere. If you worked from a finished project, you probably reached this point at least once. What basically happened is that Playworks failed to collect one of your objects for a specific reason. Past examples, this can happen for so many reasons, unfortunately. Some weird examples there from the past is I got some extracted assets from a client, and the GUIDs on their prefabs did not match the one in my scenes YML or the actual prefabs in my Unity project. One time they were part of an addressable group. All sorts of reasons. The reason doesn't really matter that much. What really matters is finding the problematic file and either tracking down what's wrong with it or simply creating a fresh version of it and the problem is gone. Yeah, you can obviously also, not so obviously, but you should look into your luna.json file if you have an untraceable error. You might see a very specific reason for that there, but sometimes it will tell you that it just failed to collect something. But if you cannot in any way stack trace back to what's actually causing your error, you have no idea what's going on, and you cannot get rid of a black screen error or a bug in your code, what I would suggest is going nuclear. And again, this is the nuclear option. You wouldn't ever have to do this if you go by the principles I mentioned earlier. You want to do what's called a binary search or a manual binary search in this scenario. Because unfortunately you have to do a Luna build after each action here. Basically, first of all, we need to find out if the problem is a script or a graphic inside your hierarchy, inside your scene, or if it's something in your project. I've had projects before that have no active scenes, only files. I didn't change anything, only did a new project and imported stuff in, and it already gave me a black screen. So what you want to do, first of all, build an empty scene. See if that works. If that worked, the problem was with your scene. If that still gives you a black screen, the problem is with a file in your project. Now, when I say manual binary search, what you have to do at the point where you understood if it's scene or project issue, you have to go in, back up your project, and you have to delete half of the files, unfortunately. After you deleted half of the files, you build again, you see if the problem is gone. Whether it is or not, you can delete half of the files again. You keep deleting half, and going back to your backup if necessary until you track down the bugger that's ruining your build. This can take a lot of time. I know we don't want to ever reach this point in the first place. Obviously, if something is wrong in your scene, you delete half of your scene instead of half of the files in your project. About bugs that you may find that have no explicit explanation, everything built fine, there's no errors, but a mechanic is simply broken in your build. I'll quickly, you know what, I'll probably show it in the Q&A section, but for now I'll only mention that while we can use breakpoints, in the age of AI, I personally prefer to just tell my favorite LLM to absolutely blast every piece of script that touches this broken mechanic with many debugs. And I, in one build, can simply go and see exactly where my debugs stop. Usually, I'll go to that part of my code and immediately see a very Playworks-ish issue there that's very obvious to me, and I can go from there. Or simply, if I don't know what's wrong, I can rewrite that method and bam, the issue is gone. All right, onto our last section, unconventional workarounds. Stuff that I might never ever do in regular game development that I've had to do inside the limitations of Playworks. Some of these they revolve around thinking outside the box. Maybe some of you already have your own solutions. I'm just going to show a few of mine that might be relevant to you, but I did many sort of stuff like that over the years. to fit within the 5 megabyte size limit to reduce loading times. First of all, in third person or first person games, I really like doing fake 3D environments. A lot of the time in sort of projects like this, I'll find myself having to use many props in the background. In this bottom game over here, I had like a huge entire city filled with many buildings, even NPCs standing around. In the top one, I already had the zombies and my shooter player character taking up all the size, so I didn't have space for all of these models and all of the textures and the entirety of the map and stuff like that. What I basically did, I wrote or maybe copied or a combination of the both. I wrote a script that takes my perspective camera and it basically takes a screenshot of the environment in each and every direction, 6 directions in total, and basically constructs my entire environment onto textures. And this is pretty much how a skybox works. This is just a square that's around my player and it's unlit, it's faking the environment. And most of the times, you then only have to manage the size of these 6 textures, which can weigh a lot less than all of these models and their own separate textures. And this usually weighs a lot less than all of those models. Yes, this is also very size heavy. But what I also do is I try to focus sort of balancing the blurry and unblurry parts between the parts that the player will actually look at and the parts that the player will only see on the very sides or only in landscape or stuff like that. Here in the shooter, I also limited where the player can look, both for gameplay reasons, game design reasons, and size reasons. So the sky is very blurry, all the sides are very blurry, and the texture behind them doesn't exist at all. Over here in the bottom one, I had to have both directions because I have the full spin. That makes it also look very 3D. A lot of the time, your players cannot even notice the difference if you did this right. Also, all right, next to 2D, 3D hybrid. Texture production. This is basically just regular 2.5D, not anything groundbreaking. But the reason I'm bringing this up is because a lot of the times we'll want very high fidelity 3D objects in our playable. Stuff like this beautiful coin pusher machine here. Looks like something that was rendered in Blender for like a few minutes even. Even in regular Unity real-time 3D graphics, we'll still have a hard time achieving something like this. And in Playworks, inside Playables and WebGL2, it's even harder. What you want to do in such a scenario is generate or design your own 3D model that looks beautiful as a sprite, or maybe you want to take a screenshot of something already pre-made, and you simply want to either use that as a rotated sprite that's like a billboarded sprite that's rotated towards your camera in your scene, or projected onto an actual 3D model if you know how to do that. 3D projection from the camera inside Blender or another program of the sorts. And then I just go in and I place all the colliders in the correct spots. A huge pro of this, using this sprite like this, is that anyone on my team, including me, we can all go and simply switch this machine out for another machine as long as it has the same peg placements. This way we can test immediately many different themes, or maybe we can reskin this for another concept within the same company if for whatever reason, if this is relevant for more than one of our games. Obviously, we cannot move the camera too much here. Here I have a slight zoom. This is not relevant for any type of playable. And this object here that pushes the actual coins is a 3D mask. I used a stencil shader to mask this object, and it actually appears as 3D in the scene and pushes my coins. And onto my final workaround that I want to show you today. Physics-driven particles. This is excellent for any scenario where you want to have thousands of objects on your screen. Now, most of you probably already encountered the obvious issue that even 50 physical objects will cause FPS drops in your playable. 500 individual game objects with no scripts that don't use physics, even them, if they're not batched correctly, can cause major performance drops. So what I want to do in this scenario, I want to create a manager, basically, that imitates physics for me or imitates enemy behavior if you maybe want an army of enemies. And by writing a script that imitates physics and uses the particle system for rendering using get particles and set particles, I can have even 1,300 props in my scene. This is a specific number that I can have here before my performance drops from moderate to poor. The way I specifically did this here is that I pre-calculate where my objects should drop off to, and I have that just as imaginary positions and numbers. And I tell them at what spaces they should stack on top of each other. If they do stack on top of each other, in relation to the positions between them, I tell them to rotate accordingly to make it look like they're sitting on top of each other. It doesn't look perfect, but it really passes for, again, a 20 to 30 second experience. We can cut some corners and the player will still receive the exact same experience. Big real games also use this method for simulating huge armies. After I have all of the positions and rotations pre-calculated in my scene, I can simply go to my particle system and tell it, using get and set particles, where each particle should go according to this array. And it really looks like they're falling to the ground. And once my hole is above them or close enough to their position, I can tell them to simulate gravity by simply changing their Y position. And once the Y position is low enough, I collect them. You can do many stuff with that if you want to stay performant in a physics-based game. And you can get way more elaborate than the physics system that I did here. Hopefully in the future, I know that Playworks is considering implementing more physics systems. The reason physics is so rough in Playworks, like I said before, is because it was made from the ground up. All right, these were all of my unconventional workarounds. And a lot of you sent great questions in the forum. I have some of them over here. I'm going to start answering them now. Hopefully, I also answered some of the questions you already have with the materials in the webinar. The very first question is about size of playables and loading times. Question reads, how can we optimize our build sizes to ensure fast loading on low-end devices and weak networks without sacrificing visual quality? And what are the best practices for optimizing loading times? Okay, so this is a very good question. Let me actually demonstrate something. Let's start with startup time, the amount of time it takes for our playable to load. And if any of you didn't consider this up until now, if my playable takes 7 seconds to load, but my player can skip the ad after 5 seconds, a lot of players are not going to see your ad in the first place. Let me go over to one of my playable ads over here. This is just for a simple objects matching game. I can actually see how much time it takes for my playable to start up by writing / startup right after my build develop usual line. And here it says 2.3 seconds. Now, this is on a browser. How can I know how it runs on a bad mobile device? I can go over here to phone mode. Now, I think in the past, up until not so long ago, I could activate throttling over here. But I think they moved it here. Yeah, CPU throttling. I'm going to simulate a mid-tier mobile device. I'm going to quickly refresh this. It was 2.8 seconds before. Now it's 2.6. Not sure if it's not measuring perfect or if my playable is very optimized. Hopefully it's optimized. But after you see how much time it takes to actually load up regardless of whether you manage to simulate a low-end phone or not, you can see what takes up what percentage of your loading time. And the thing that a lot of people miss, a lot of people think that only the size of your playable matters, but actually there's another variable here that very much matters: the scene loading and awake time. If you are starting your scene and you're immediately spawning into maybe use a pooling system, a pooling programming pattern, and you immediately spawn 100 objects, your scene loading and awake are going to increase due to that. So you want to see how much it actually takes out of everything over here. You can also see how much time it actually takes to load from the network, and over here it actually says optimize with size breakdown. But specifically about loading and in start and awake, you want to make sure to not instantiate too many objects. You want to make sure to not get components too many times in your awake. The way you do this is you pre-bake it before you build. If you have a pooling system, you make it so you have a button to pre-spawn them and clear those pre-spawned items. And before you build, you pre-spawn everything. You pre-populate as many fields as you can. I know this is a bit less dynamic, but this really helps us save on performance. So whatever you can do in advance that will get saved from your loading screen, I highly suggest that you do that. But the question also asked about actual loading time and best practices. So if I go onto my actual project over here, I go onto, obviously a lot of you already do this, but I'll tell you precisely what I do. If you're not familiar with size breakdown, you should absolutely stay aware of it and do this every time you import, every time you finish a project. I actually only do this when I finish a project, or if I expect my assets to weigh way too much. You pick your platform. I use Iron Source or Unity Ads. I estimate. I know that this is not entirely accurate, but the fluctuation is only like 300 kilobytes there or there. And usually Playground is actually lower than what you see here, which is good for you. Like if my playable is 5.2, I usually uploaded it and it's still fine. You build and you go over each and every one of your files here and you find the biggest offenders. And when I say biggest offenders, I mean go into your textures, for example. Usually you'll see that maybe there's a texture here that suddenly weighs 400 kilobytes or 600 kilobytes. This one weighs just 70 kilobytes. Now, don't skip those textures. We can also save here. This is just like a random alpha texture. I doubt the player will see if I change it. So the default is 512 by 512, small size. What I do is I take it to 256 by 256. I recalculate. And this will go out down from 74 to, I estimate, maybe 24. We'll see in just a second when it's done loading. Hopefully it's not stuck. If it is, I'll show you on my other project simply. While this is, oh, it's already done, yeah. 21 kilobytes, perfect. Now, you don't want to go over to your assets and go to textures and put any high value here. On your default texture settings. I know that your thought process might be, oh, everything needs to look beautiful in my project, but you don't want to do that defaultly. You want to go over each and every one of your textures independently. What do I do if something does look blurry in my playable later? You talked about keeping the quality. The values I usually use if I want something to look pretty and it's blurry currently, I take it to double the texture resolution size. So from 512, I take it to 1024 by 1024. And I also take it to best quality. Sometimes this doesn't even greatly increase file size. One exception is the sounds. You can take this to 64 instead of 128. This is the best way to save size, in my opinion. If you have a background music or anything, this can take like immediately 400 kilobytes off of your build just by decreasing the audio bitrate. You probably won't hear the difference between 120 and 128 and 64. A new thing that got recently added is you can reduce mesh complexity. I don't suggest doing this for all of your models unless you have to. You again go and find your biggest offenders, like this dress here that might be way too complex, even though it only weighs 50 kilobytes in my case. And when you reduce it individually, you can see after the reduction whether the reduction messed up your model or not. You want to stay aware of this. This is why you don't want to do this globally, because on specific models, it can start creating holes. It can be not perfect. You can create overlapping and Z-fighting bits. Over here in my dress, I can see I have holes in the connection point. This means I need less reduction. So these are the best ways to keep file size down. Obviously, you should focus on stuff that your player will see most of the time. If there's a graphic that your player only sees for 1 second, maybe something in your retry screen, you can prioritize different parts of your playable depending on that. Not everything has to be perfect, honestly. You'd be surprised at what players might look over. All right, this is it for these question. Again, to summarize, cache as much as possible to save on startup time, and go one by one and find the biggest offenders in your size breakdown and take care of them. Next question is about
May I add something, Shahar, to that question? Yeah. The question you just answered. We are actually also working together with the Unity network team to make the playable performance based on the device that we're looking at. So similar to if you have a PC and you're playing a game and you can adjust the graphics based on the PC or whatever you're working with. We are actually in the process of making something similar for the Unity network. So if you have a low-end device or a poor connection, the playable will be smaller, more compressed, but the performance of the playable will be better for the device itself versus the other way around. High-end device with a good connection, it's able to carry a bit more heavy playable. So that's something which is done on the network side. So not so much on the plugin side of Playworks itself, but it's something in the works, which I think is also pretty exciting. Back to you, Shahar.
Okay, so we only have 3 minutes left. I'm going to blaze through 2 more questions about not so technical stuff, actually. There's a question here about metrics. How can we track metrics like full load rates, interaction rates, total play time, and finding the sweet spot for playable length or player drop-off, stuff like that. What's basically described here is the Playable Insights system. Unfortunately, this is only for paying users, if I'm not mistaken, of Playworks. All you have to do is simply write the correct analytical event for whatever's happening in your code. Let me actually quickly demonstrate what it looks like, not behind the scenes, because you can simply look at the documentation if you want to implement anything like this. But if I go to maybe Asylum Let's Play, yeah, that's a good one. I can show you the actual metrics and the results of this, but I can show you the events in action. I can see what configuration just launched, and whenever I perform certain actions in my playable, first of all, I have this engaged event that just fired. The player moved enough for me to know that they are trying to play. First patient cleared. And then I have all my next steps, upgraded the first clinic, stuff like that, so I can know exactly where my player dropped off. I have to move on to the next question, retention and call to action. Again, there's a great docs page on this. Design your playable, must-have features. Most of what I'm going to say is already covered here. Basically, tutorial and hints to carry the player through the playable. And the persistent CTA, you can see both of those already here in the playable I just showed. You have a banner to play now. This is consistent for the playable. If you click that, you go to the store. I always have an error showing the player where to go. I know this can feel like hand-holding, which might be a scene in some game design circles. But in Playables, you always want to hold the player's hand throughout the entire thing. If they didn't interact for a bit, you want to show them a hint again. Independent players will want to defy you and play whatever you show them not to do. They'll do the opposite. This drives up engagement. Non-independent players will simply you'll simply keep their attention span using stuff like that. Highly suggest tutorials and hints to keep them on hand. And this was all the time we had, unfortunately. Thank you, everyone, very much for coming, for listening. I wish you all the luck in
May,
your.
may, yeah, may I have the final words? I just wanted to say, I think it's clear that the product itself, it isn't perfect, as in it fits one-on-one with the Unity engine. So I think hopefully this session is super useful about like the workarounds and how an expert like Shahar deals with the limitations that are also there. The Playworks plugin is not just like a mimic of the engine, right? It's an engine on itself on top of the Unity engine, so it's a lot more complex because of that. I just wanted to say the participation of all of you has been amazing. I see there's more questions also being asked in the chat than we are able to answer right now. So I'll try my best to also go over some questions after together with Shahar and see if we can answer them individually. There will also be a feedback form, so we'd love to get your feedback on this. We would love to hear if there's something you'd like to learn more about, and also what you think about this session. And I also just want to say that all you developers are really amazing. Like the things you build, the out-of-the-box thinking required, the creativity required is really amazing. Thank you, Shahar. I think from my point of view, this was really useful. And yeah, maybe once more back to you for the final words.
I just wanted to thank everyone for coming, basically, and wish you all a lot of luck in your playable endeavors. And that's it. Thank you very much.